My name is Dr. Liz Haro, and I am the Human Systems Integration Senior Scientific Technical Manager. So as the HSI SSTM, my responsibility is to advance our strategic thrust when it comes to HSI. We have an HSI community that spans across all of the syscoms, all of the different services, and we work very closely with them. The HSI community has worked very hard, and for the most part, it's a little bit of a labor of love. We work very hard to represent that operator subsystem. And that means having fleet interactions and bringing their needs and their safety very early into the process. This is really gonna facilitate and enable that additional reach and depth of work that we've been trying so hard as a community to work. For me, HSI is the opportunity to bring the human need and the human element into the system engineering conversation. You're gonna have a solution that is a lot better for your operator. I have been on multiple ships and I have seen what being a warfighter is like, and it's not an easy thing. They work very hard to complete their mission, and if we can facilitate their living spaces, their tools, their processes, then I consider that to be a small contribution towards what they're doing.
My name is Sarah Mayton, and I'm a human factors engineer here at Dahlgren. I do a lot of space design and integration projects, and I'm directly impacting where watchstanders are spending 8 to 10 hours of their day. I'm making their job easier. I'm making it more effective and more efficient so they can, at the end of the day, protect us here at home. One of the capabilities we have here in the Human Performance Lab is space design and integration. What happens is we have a sponsor come to us and they're designing a space, typically on a ship, and they want to optimize the space for effectiveness, efficiency, and usability. The beauty of this is I can sit one-on-one with a sailor and say, here's all your equipment. How do you think it should be designed? And they get to physically move the pieces, say, no, I, as this watchstander, need to sit closer to this person. And then we take down their notes, why they say what they say, and snap a picture of it. And then from there, we come to this space where we actually build a large scale model, which is all behind me. And here we do something called a red cell. And then that's also when we bring in all the stakeholders. So you have your systems engineer, you have your Chings, you have your sponsors. After we've done that event, we then go to a cognitive walkthrough. So a cognitive walkthrough, hopefully by then we're down to 1 or 2 layouts, and that's when we actually get to bring the end users, the sailors, into the space. So in that situation, they're gonna, sit down, and usually we have a sailor in every single chair and we're walking through. That's when we can find out things where maybe this watchstander says a comment about, I need this piece of equipment that's all the way back there. So then we can just physically pick up that equipment and say, okay, what if we put it here? And then we also have all of our engineers to make sure that it is capable to be moved here. So after the cognitive walkthrough, we incorporate all of the feedback we get from the users and also the stakeholders, and then we also incorporate our expertise as human factors engineers and hopefully come up with one final design that we deliver to the sponsor.
So one of the things that we're trying to do, and I know Dahlgren as a whole is trying to do, is establish our partnerships with academia. We are looking for the next talent. We want to be hiring at the quickest level we can, which sometimes means high school, future engineers, mathematicians, scientists, etc., because we want them to see what we do. When you're growing up, you're exposed to what you know, what your parents do. And so the DoD or government work is not necessarily something that a lot of our students know about. So stepping in early with STEM really puts us into that perspective and allows them to understand that there is some very good work that they could do, and they can facilitate their engineering degrees with us. STEM is that first part of education, of getting them excited and getting them aware that we are a possible employee for them, and a very good one at that.
All the nitrogen's gone. The purpose of the water was to give it what's called a thermal mass that could boil that nitrogen away. And because all of these holes were poked at an angle, it created a twist in the bottle. And I had lots of little holes in there, and it works out. I'm Daniel Wallace. I am a human factors engineer. I am the technical warrant holder for displays in human factors engineering. I am actually a NSWC 05 billet, but I'm seated with the Dahlgren folks. I work very closely with them. I really love the opportunity to mentor and to do some of the actual engineering work that's done down here. It's really exciting. I'd like to make sure that we get the best and brightest engineers coming in to work for the Navy. I try to make sure that they have a more robust understanding of really what STEM and science and engineering is about. I can influence the next generation, and even more so, I can influence them to influence others. They don't know it all, that they need that mentorship, that they needn't feel bad if they don't know something. Great, let's learn something today. This is your lucky day, you get to learn something.
My favorite part of HSI is the direct interaction with the users, and we get to have that personal connection, and after you spend a week with them, you kind of get to know them and joke around. So I really like being their advocate and getting to know them and understand some of the difficulties that they go through and try to advocate to make their life better. One of the beauties of the space design is that typically we get brought in at the very beginning of the acquisition cycle, so we can have the most impact and we can really be flexible with the design. One of the struggles of HSI is that a lot of times we get brought in at the end. If you incorporate that feedback in the very beginning of the design, you're just gonna have an overall more effective system and design for the end user.
In order to effectively do HSI, you've got to do it early because if you come up with a design, you start implementing it, there's a lot of engineering that has to go into a system design, and you find out later that this isn't really gonna fit what the operator needs. There's a lot of reluctance to make those changes because it's gonna impact costs, it's gonna impact schedule, it's gonna impact a lot of things. What is the need? What is the capability gap that we're trying to fill? Because sometimes we don't do that explicitly. We say, oh, we need a new gun, okay, let's build a gun. Well, wait a minute, why do we need a new gun? What are the failures in the other one that make us feel like we need a new one? Okay, or in the case like this space here, why do we need a different command space? Well, that command space is going to be doing a different mission. And so we have tools to do that. There are link analysis tools. One that was developed right here in Dahlgren actually, called SALT, which is the spatial analysis link tool, where we literally can analyze objectively the arrangements, physical spacing between people, the frequency of interactions, the criticality of those actions, what modality those interactions are in, so that we support the auditory, the visual, the physical considerations of that space.
When you think about living in the space that you work and doing the kind of work that they do, it really resonates to, we have to optimize for them. And we have to give them tools that they don't have to solve how to work it within a high stress, high sea state, wartime environment. Our job is to give them something they can use, and they can come back and be like, that really rocked, that was very good. I didn't have to think about it, I was able to use it. Knowing full well that the fights that we're doing here internally to be represented and to create solutions and capabilities for them that are going to perform the way they need to perform, that is what gets me up in the morning. We as humans are very variable. We are a product of our mental models, how we learn, how we grew up, and we are all very different. And so being able to understand that variability is what we bring to the conversation.
I really believe that I save lives. I really do. I believe that there are things that I've discovered along my career that this has removed the likelihood or reduced the likelihood of operators making a mistake. You can make a difference. It's very hands-on. You're going to make things better for the fleet. There's some seamen that are going to be able to come home to their families that might not have otherwise, because the systems are better engineered because Dahlgren was involved.